Hello and welcome to this video in the GCSE Math series. Today we'll be covering inequalities. What are inequalities? And before we talk more about this, let's start asking ourselves as to what equations are. Now when I say equations, you might think of an equal to symbol, and that basically means that any quantity on your left hand side equals a quantity on your right hand side. So if I say x equals 2, that means x exactly equals 2 in this given instance. However, this is slightly different to inequalities because inequalities are used to make comparisons. So if I was to say that x is greater than 2, that means x can take any value that is greater than 2, or any other value that x takes has to be greater than 2. Now, they make use of all these symbols. So it could be less than or equal to, greater than, or greater than and equal to. Now, for instance, if you had y being greater than or equal to 2, that means that y can take any value as long as it's 2 or above. Now, this is slightly different to y being greater than 2 because in this situation, y can take any value, but it cannot take 2 as its value or any other value that is less than 2. So in this case, y can be 3, 4, 5, and so on. But in the former case, y can be 2, 3, 4, 5, and so on. And the same thing translates to less than or equal to symbols as well. So if I had z is less than 3, that would mean z can be minus 1, 0, 1, and 2, or any number that is less than minus 1. Now, in order to visualize inequalities, we make use of the number line. So if you had x is greater than 2, we first locate where our 2 is, and we draw a circle above it. And now, because x can take any value greater than 2, we draw an arrow to represent all these permissible values. Similarly, if x is greater than or equal to 2, we first start by locating where 2 is, just over here. And the difference here is that we now shade it in to indicate that this is greater than or equal to. And then, as before, we draw a line that points to the right to indicate that it can take any value that is greater than 2 as well as 2. Next, if we had x is less than 4, we again start by indicating where 4 is, draw a circle above it, and then, unlike the previous case, we draw a line that extends to the left. Now, it doesn't matter how long you draw it, but as long as you draw it as a line that points to the left, that's all that matters. Likewise, if you had x is less than or equal to 4, you again locate your 4, except in this case, you shade it in. And that is indicative of your less than or equal to case. So you draw your line that points to the left, and there you have it. Next, if you wanted to draw something like this, you first indicate your two values of interest, that is your minus 4 and positive 4. Now, because these are both less than or equal to symbols, you don't shade them in and just draw a line that connects these two circles. For this case, where x is sandwiched between 0 and 3, except x is able to take 0 as its value, you again locate your two numbers, so that's your 0 and your 3, but you shade the circle above 0. And as before, you draw a line that connects these two circles. Now, solving inequalities is just like solving equations, with a minor difference, but this is something we'll cover in a moment. Now, suppose you had x plus 5 is less than 3. Just like as you would solve equations, you take away 5 from both sides. So you get x is less than 3 take away 5, and that gives you x is less than minus 2. Next one. If you had 2x plus 5 is greater than or equal to 3, you take away 5 from both sides. So that gives you 2x is greater than or equal to 3 minus 5. Now, as you can see, I didn't really care whether it was a greater than symbol or greater than or equal to. I treat it just like an equation. So that gives me 2x is greater than or equal to minus 2. So therefore, x is greater than or equal to minus 1 when I divide through by 2. Now, in this question, you have x plus 5 is greater than 3x. First thing we want to do is collect the like terms. So we get x take away 3x, and that's greater than or equal to -5. On the left-hand side, you get minus 2x, and that's greater than or equal to -5. Now you might be tempted to say that x is greater than or equal to 5/2, but that's not quite right. And the reason is the inequality flips when you multiply or divide by a negative number. So what you do here is that you write x, but then as you divide through by -2, you flip your inequality, and that gives you x is less than or equal to -5 over -2. Your negative signs cancel, and that gives you x is less than or equal to 5/2. So in a nutshell, inequalities are used to make comparisons, and they can be solved just like equations, except when you try to multiply or divide your inequalities with negative numbers. That's when you flip your inequalities. Thank you very much, and have a good day.